Good afternoon, my YouTube viewers. It's Crystal here. I just wanted to make you another video. In my last video, we were talking about empirical probability, and that's probability that you have already tested, and it's practical experimental probability. In this particular video, what we're going to be talking about is theoretical probability, and that's not based on true experiences. It's just going to be based on the theoretics of it. So that's your difference between empirical probability and theoretical probability. So we're going to go through 10 probability questions with theoretical probability. So the first question is, what is probability of rolling a 4 on a fair 6-sided dice? So the number of sides is 6. The number of favorable outcomes is 1. So theoretical probability equals the number of favorable outcomes divided by the number of sides. So that's going to be 0.167. And so the next question that we have for theoretical probability is, a fair coin is flipped twice. What is the probability of getting 2 heads? So your number of outcomes is going to be 4. So that's going to be heads, tails, heads, tails. That's your number of outcomes. And so you can have head, tail, head, 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 tail, tail, head, tail, tail. So that's 4 outcomes. And the number and the outcome that you want is going to be tail, tail. And so the theoretical probability is num desired divided by num outcomes. And so that's going to be 0.25. Since you're going to have 4 outcomes. And let me just go over the 4 outcomes again. Head, 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 tail, 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 head. And then so since the theoretical probability is going to be 1 divided by 4, so that's going to be 25%. So the next question we have is, what is the probability of drawing a heart from a deck of 52 cards? So your number of cards is 52. Your number of hearts is 13. So the theoretical probability is number of hearts divided by number of cards is going to be 25% as well. The next question is, 2 fair 6-sided dice are rolled. What is the probability of getting a total of 7? So the number of outcomes is going to be 6 times 6. So because you've got 2 6-sided dice, so that's 6 times 6. The number of desired outcomes is going to be 6, because you can have 1 plus 6 is 7, 2 plus 5 is 7, 3 plus 4 is 7, 4 plus 3 is 7, 5 plus 2 is 7, and 6 plus 1 is 7. So you've got 6 desired outcomes. So your theoretical probability is number of desired outcomes divided by number of outcomes. That's going to be 0.167. The next question we have is, a bag contains 4 red, 5 blue, 6 green marbles. What is the probability of randomly pulling a blue marble out of the bag? So you've got red equals 4, blue equals 5, green equals 6. Total equals red plus blue plus green. Theoretical probability equals blue divided by total, and that's 0.33333. The next question we have is, in a group of 23 people, what is the probability that at least 2 share a birthday? And you have to use the complement principle. So you're going to have, from math, you're going to import factorial, and then we're going to create a function to do that. So def birthday problem brackets n, so n is going to be the value that it accepts as input. So we're going to calculate the probability that at least 2 people share a birthday in a group of n. So if n is greater than 365, return 1. It says more than 365 people guarantees a shared birthday. Problem number shared equals 1. Start with the probability of no shared birthdays. For I in range n, prob no shared equals prob no shared times 365 minus I divided by 365. So prob shared equals 1 minus prob no shared, and you return prob shared. And then so we have the example usage. Number of people is 23. Probability equals birthday num people. And so it's going to take 23 as the input number. And then you're going to print the probability that at least 2 people share a birthday in a group of 23, and that's a 50% probability. So we have another question, which a fair coin is flipped 5 times. What is the probability of getting at least 3 heads? So we're going to use the Python's inbuilt library called math. So from math, import com, and then we're going to create a function for that, probability at least k heads, and it's going to accept n and k as inputs. So calculate the probability of getting at least k heads in n coin flips. So p equals 0.5, probability of heads in a fair coin flip. Probability equals sum, brackets, cum, brackets n comma I, times p to the power of I, times brackets 1 minus p to the power of n minus I, for I in range, brackets k, comma n plus 1. And then you're going to return the probability. So we have example usage for 5 flips and at least 3 heads. So number flips equals 5, k heads equals 3, probability equals probability at least k heads, brackets n flips, comma k heads, and then you print probability of getting at least 3 heads and 5 flips is 50%. So we have another question. What is the probability of drawing 4 of a kind in a 5-card poker hand? So we're going to import random, and from collection, we're going to import counter. And it says we're going to create a function called def generate poker hand. So suits equals hearts, diamonds, clubs, spades. Ranks equals 2, 3, 4, 5, 6, 7, 8, 9, 10. J, Q, K, A. And deck equals rank of suit for rank and ranks for suit and suits. And it returns a random dot sample deck, brackets deck, comma, 5. So you draw 5 random cards. And then what we do is we check 4 of a kind, and then it's going to accept hand as the input. It's going to check if the hand contains 4 cards of the same rank. Ranks equals card dot split, brackets 0 for card in hand. So it's going to extract the ranks. Count equals counter, bracket ranks, and it's going to count the occurrences of each rank. Return 4 in count dot values, brackets. So it returns true if 4 of the same rank exist. Now we have another function, def simulate poker hands, brackets num simulations equals, it looks like 100,000 to me. And then we're going to simulate poker hands and estimate the probability of 4 of a kind. 4 of a kind count equals sum, brackets 1 for underscore in range, num simulations, if check 4 of a kind, generate poker hand, brackets, 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 brackets. Estimated probability equals 4 of a kind divided by num simulations, return estimated probability. Then you run the simulation. So number of trials is, it looks like 100,000 to me. Probability estimate equals simulate poker hands num trials, and you print estimated probability of 4 of a kind and a 5-card poker hand, and the estimated probability is going to be 0.027%. So we have another question about theoretical probability. A factory produces 1,000 items, of which 10 are defective. If 2 items are randomly selected, what is the probability that both will be defective? So we import random, and we create a function called simulate defective simulation. So num trials equals, it looks like 100,000 to me. Simulates selecting 2 random items from a batch and estimates probability of both being defective. Total items equals 1,000. Defective items equals 10. Successful trials equals 0. For underscore and range num trials, and we're going to create an item list. 1 equals defective, 0 equals non-defective. Items equals 1 times defective items plus 0 times total items minus defective items. And then random shuffle items. Then we select 2 random items. Select equals random.sample brackets items, 2, and then check if both are defective. If selection 0 equals 1 and selection 1 equals 1, successful trials equals successful trials plus 1. Estimated probability equals successful trials divided by num trials, return estimated probability. So then we run the simulation. So the number of simulations is 100,000. Probability estimate equals simulate defective selection brackets num simulations. And then we print estimated probability of selecting 2 defective items is it's really low. It's going to be like a 0.009%, something like that. But let me just check. If a factory produces 1,000 items and 10 are defective, okay, well, we'll just leave it here as it is. So the next question we have is, an arm contains 5 red, 3 white, and 2 blue balls. If you draw 2 balls, what is the probability that both are red, given that the first drawn ball is red? So we're going to create another function. It says define conditional probability red brackets, and we're going to compute the probability of drawing a second red ball given the first drawn ball was red. Total balls equals 10. Red balls equals 5. Probability of drawing a red ball first. Probability first red equals red balls divided by total balls. Probability of drawing another red ball given the first ball was red. Probability second red given first red equals red balls minus 1 divided by total balls minus 1. And return probability second red given first red. So we compute the probability. Probability equals conditional probability red. And then we print probability of drawing a second red ball given the first was red, and that's 44%. And so that was your 10 questions in calculating theoretical probability. And so the next video that I'm going to making is going to be calculating empirical probability in Excel. And then the next one after that is going to be calculating theoretical probability in Excel. So we're going to be making these calculations a little bit different way, but it's going to all have the same values. So thank you so much for watching this video. If you like my video, please like and subscribe. And I look forward to making the next video for you, probably tomorrow.